So this is really going to be very quick, I'm recognizing, but we're thinking about what is the volume of a prism, what is the volume of a cylinder, what's the volume of a cone, the volume of a pyramid, and the volume of a sphere. Well, when I'm thinking about this, right, we know the area of a polygon, right? And so essentially when we're thinking of volume, we're thinking how much space is being taken up. Well, in calculus, what you're going to be doing, which, you'll get there eventually, I hope, what a lot of calculus is about is considering the sum of lots of very small things. So you notice I have this big prism, and I have this green cross-section and this red cross-section. Well, both these green cross-sections and the red cross-section both have the area that's the same as the area of the base, right? All we're doing is translating. And so I have some sort of area of the first base, area of base 1, and then I have the area of cross-section 1, and then I have the area of cross-section 2, and then up here I have the area of base 2. But at the same time, I know that all of those things are equal, right? The area of those different polygons is always going to be the same because the polygons are congruent, right? Based on the fact that all I'm doing is translating the polygon. And so really I have kind of the area of base 1 plus the area of cross-section 1 plus the area of cross-section 2 plus the area of base 1, which really those are all just the area of base 1. Oops, sorry, that was the area of base 2, but they're all the same as the area of base 1. So I'm kind of saying, okay, so for every cross-section, which obviously maybe there's only 2 bases, but there's an infinite amount of cross-sections, right? Plus the area of cross-section 1 plus the area of cross-section 2 plus the area of cross-section 3 plus all of the cross-sections plus the area of base 2. And all of these are the same, so I'm adding up the area of base 1 plus the area of base 1 plus the area of base 1 plus plus wherever we end, the area of base 1. Okay, they're all the same. And so how do we represent that in volume? Well, what allows us to find a volume? How do we know when we're going to stop? Well, that, of course, is going to depend on, well, how tall is my prism? How far am I translating? Right? And so really what we're doing here is just recognizing that there is some sort of altitude here, and that is going to give us a representation of how far have we moved. And so this is what we're going to call h, or the height. And remember, this is going to be perpendicular to both bases, because when I'm translating the bases, those bases are going to remain parallel to one another. And so my height is this altitude, and then all I have to do is take the area of base 1, which we'll just call the area of the base, right? And then we will multiply by the value that is the height, because this is going to tell us how far did we travel, how many cross sections essentially are we adding up. But of course you know that this has no width at all, right? This is just a polygon, and it's on one plane, and a plane has no width. So that's why we kind of are moving into some calculus topics where we're thinking about adding all of those tiny, tiny, infinitely small pieces together and somehow ending up with a number that is the height. And how we're going to write this is we will write that the area, oops, not looking at area, we're looking at volume. The volume of the prism is going to be equal to the area of the base, capital B is going to stand for area of the base always, and times h, which is the height of the prism and also the distance between the bases. Kind of means the same thing, right? The distance between those two bases. So there's your volume of the prism, and you can see that as for a cylinder, it's going to be exactly the same process. And for a cone and a pyramid, you may have noticed that the volume of a cone is 1/3 area of the base times the height. And the volume of a pyramid is 1/3 area of the base times the height. So if you go to that next website I'm asking you to go to in lesson 16, you will see some explanation of why we have that 1/3 in there. It's definitely an easy thing to do in calculus, a hard thing to do in geometry. So you're going to have to look really careful at those diagrams and what they're trying to show you and see if you can work those out.